Hello, people. I'm kind of confused. Oh. Now we set render target. What's going on? We're not going to implement that paper today. We may do that at some point in the future, but after thinking about it, after thinking about the amount of expense that technique requires versus what I get from it versus what I actually want, I'm just not sure it's the right trade-off. Now, I was realizing some things. For example, well, okay. So if I'm looking at a game like this, obviously this looks kind of messed up and not that interesting. Like one of the things we're going to do today is maybe just do some random things until we can get back to a place where this is looking a little bit more interesting. But we don't, like I said to Casey during that session, we don't actually want water simulation most of the time, right? So like in this scene, maybe I want water simulation in the active rivers, and maybe I want it for a brief period when I drop something in, for example, and it makes splashes that radiate out. But for the most part, we just want a controllable background. And because of that, like that technique that we looked at the paper for is really overpowered. That technique is for, hey, you want to make waves in a bunch of places all over the place and have them many alive at the same time and all propagating and look realistic. And we don't necessarily care about any of those things. We don't even care about looking realistic. We just want to look good, right? Which is a different thing. And so I want to go back to square one. I want to go back to the thing that I was doing here way back with these particles. And I just want to start improving it and just see what it ends up looking like, right? Like each of these circles, I want to turn it into like a little wave that bounces up and down, and then give us some control over that and see what it looks like when we blend them. And that might already be too much to do in a day because just dealing with shaders is annoying, but maybe not. You know, because the thing is that paper that we were looking at for the quality levels that they were showing, they iterate 120 times per pixel over a non-trivial loop. And it's like, well, we don't want to spend that much. But like I said, we don't necessarily have to spend that much. So if we were going to use that technique, we could actually, I realized today, we could limit it only to these active regions here and do something else in the background. But then you have to like style match those things, which might not be that hard. I don't know. So if we implement that technique, that's probably what we would do. Um, and you could, in fact, because that technique is about representing these waves in a quantized way, we could use that representation everywhere else in the ocean and just like not really run a sim. I don't know what that would look like with that particular technique. Anyway, people. Anyway, and the other thing to say is no matter what the mechanism is to move waves around, we still need to do the other parts of rendering, which is like making it look good in terms of, just getting the specular back on there, just having that structure, and so I just want to work on some of that stuff today. Because honestly, a lot of things here are kind of fixable. Like when you start thinking about things and you just have time to sit back and not stress about them, you start to see solutions. So for example, one of the problems with this particle method is like, hey, these particles down here, when they hit a corner, they tend to pile up on this side of this river, right? And so you tend to have underrepresentation of particles around here until you pass the particle lifetime and some of them die out. And so that means then if you have a much more active river, you might be really messed up. And anyway, you're wasting a lot of your pixels up here and not very many down here, right? But, that's a little bit solvable by just, when you generate a particle, give it a parameter of how far laterally you want it to be in the row that it's traveling in, right? Because this game is about rows and columns anyway. We don't want a lot of maybe for free random ocean particles, we could do that. But for stuff like this, it's like, let's just say, I like to be 0.7 of the way over, right? And so until he's 0.7 of the way over, right, the force that he feels by this thing pulling this way is mitigated, let's say. You'd have to formulate what that is, but the point is, the reason you would pre-pick that per particle is to make sure that you have an even distribution at all times, right? And so that way you wouldn't have things piling up on one side like this, right? That's all. So you can do some things like that to fix what some of the basic problems are with this technique. And yeah. How many lines is the game? It's between 90 and 130,000 lines, depending on how you count. Anyway, our goal is just to either have this looking better by the end of the stream or to have learned something. And the thing is, I don't even remember. My impression is that these circles are like being rendered into an intermediate buffer. And I'm not seeing that in the code, which is weird. Because we're saying main color target and then water particles render. But I feel like draw entities water actually changes the frickin' render target. We might just start by investigating these things. Because I'm pretty sure when we draw the ocean, we're just drawing a plane and then with all this stuff in there, right? Okay. No. I don't know what the mask buffer is. Like, do we even need that? What? Is that the thing for the characters? I don't know. Anyway, update fluid sim. So water foam target, that's fine. This is weird. So, but like, I think if I just start changing what we output, so from this shader, I think that I can't, sorry, that's not the shader. I don't think I can just straight up output color, because what we're doing here, we're setting the Z coordinate and that's getting translated to like grayscale for some reason. And that's not, this is like an artifact of the way that things were set up, and it's not okay. So we want to change that because we want color control. So like, I don't even know where this data is going, right? But if I say like result.r is 1, that's not going to give us, like, that's being used to do something. That, like, I don't even know what, or, sorry. Yeah, X, I guess that's the same. Can you say .r in OpenGL? I guess you can. Okay, so see, like, this is all like vestiges of some experiments that were going on a long time ago that are not really relevant. So Y coordinate, maybe that's a normal. Z is like being used for, I guess, amount of foam or something. And then W, like, I don't even know. We have to figure out what is going on here. The first thing I have to do is get control over this situation. Because it's not set up, no matter what, if we have particles moving around, we want to do color and we want to do normals or depth or something like that. And so, I feel like we're going to want 2 rendered targets for it. But for our initial experiments, we need at least 1 render target anyway, no frickin' matter what. So like what? I just need to figure out. Like, the code is too spread out. It's in too many weird places. And like, I can't tell by looking who sets the render target. So let's just do a debug build. And then we're going to open okay, that's the foam. We're not worrying about that. So here. Okay, where is set render targets? Is that in OpenGL? Where is it? Oh, it's in. It's in render target. Yeah, I don't like the way that's factored. Like, what? I'm just have consistent inputs windows. Okay. It's targets. I'm already annoyed. This is not going to go well. All right. So we're just there, and well, we're back here. Apparently, we don't set the render targets, or the breakpoints don't work. So I don't understand that, because why am I not then just drawing to the main render target? Make ocean simulation, but don't simulate the rivers at all, and make them only interact with the ocean when the river change. Yeah, I mean, we'll see. I simply don't understand if you're claiming that the render targets this might not even be the thing that draws those particles, though. The above water. Yeah, those are the only two calls. Trying to think what's the most expedient way. Like, my temperament is just to frickin' delete everything. Like, not the whole game, but like, yeah. But that's probably not going to be faster than... Well, we will gradually delete everything, because what we're going to ship is going to be, very tuned. But I don't think I necessarily have to delete everything right now. I'm just really annoyed at how messy this has gotten over time. It just needs, you know, I don't know, man. I'm so annoyed. I'm just going to do stuff like this for a second while I clear my mind. All right. Yeah, so I need to understand what is going on here. So my impression was that that stuff writes to some surface, and then this thing, which is the main ocean shader, I mean, maybe those are the water foam particles. Maybe that is the foam target for some reason. You know what? Since there is no frickin' foam right now, like, that's not a thing. Let's just not even do that. So I bet that's what it is. I bet, okay, that's why I'm confused. So yeah, we don't use, no, we must use that. Okay, this particle buffer, that's what it is. Particle buffer. Yes, okay. So what's going on is these particles that we are pushing around are marked as going into the foam buffer, but we don't want that for now. We want them to just go normally. So we want to change I'm just doing random code demesses sometimes. So we want to change this particular particle source. Like, we do this thing where we make default ocean particles somehow. Add default ocean particles. Okay, so we have in the particle layer of the game, let's, okay, we've got to continue here. Let's close, close, close. All right. So we go here, whoops, that's not what I wanted. Control P from the editor. There is some particle set here called default ocean particles. No. Maybe that's a different... Oh, default water particles. There we go. It's this guy. Now you can't see that because it's like putting them around. I don't know. Should I just make an ocean here? Will we be able to see? I don't think so, because we're in the editor and like that simming doesn't happen in the editor anyway. Well, we can at least use this to edit things. It's not a very good way to do things. We're going to have to improve this later. I can't get at the group members from the frickin' editor. Come on, bro. What? All right. Maybe they're just positioned right here. Default. There's only one. So we're going to just turn off isFoam. That like might be it. Now I don't know where the weird normal map particles are coming from. Okay, this, oh, this is a thing that happens maybe in the editor? That'd be unfortunate. No. So why do they still look the same? Yeah, this is still, it's being rendered the same way, which is not great. All right, well, we're just going to be even more severe about this. If we want this, like, I don't like the way this works anyway. Like, what? Like, why do we, what? Why do we have a copy pasta of the same code here? Like, what? Who is fired for this? This is for GPU particles. This is for CPU particles. But like, all right. I just want to work on water. See, this is what happens with programming. This is the thing that happens with programming is like, if you're in a small room where you know everything that's going on, it's fine and you can actually get something done. And so first of all, as soon as you go outside of what you're used to working on, you take a penalty because like you don't know how things are, right? You don't know what files things are in. You don't know how they work. You don't know how they work. You don't know how they're designed, right? But then, secondly, you start taking this penalty of like, this just isn't reasonable what I have to do now, right? Like I have to clean up all this other stuff before I can work on what I want to work on. Um, so, and that's what, well, that's one of the many things that kills people's productivity as programmers. Um, so, yeah, like, I mean, to be fair, while we were building up the engine, it was just like, let's make a little bit of a mess because, we don't care that much. But at some point, like if you're copy pasting and you've got like, I don't know. Ugh. Like, dude, all I want to be able to do is output a red pixel from a particle. That is all that I want to be able to do. And it's going to take an hour. And that's why programming is bad right now. Okay, we're just gonna rip stuff up because if I don't understand it, it's not good. So, I hate this kind of comment too. Just if you're not going to do it, have a better explanation. All right. So, foam is not a thing right now. We'll bring it back later if we want it. Foam is simply not a thing. Like why that's a parameter to this function, I don't know. Okay. So these two lines are reasonable. Look, if it's GPU particles, it'll be handled in the GPU particle function. Okay. Like, I don't know why that's a separate loop at this level. Because shouldn't they be sorted and the GPU thing just, yeah, like whatever. Okay. So we're simply not doing this right now. It's not a thing. Let's just see if these particles have disappeared due to my doing that. All right. Well, it didn't take an hour to be able to output red. So I guess that's fine. Okay. I still don't know why it's flagged as is foam. We're going to have to figure that out at some point. Like if I go do this thing, and then I select particle source, it's still flagged as foam there. That one isn't. It might have been the wrong one. Like, there's two particle sources here, like I was saying, and there were only one over there, and I'm not sure why. But it was bad that we didn't have a visual on that anyway. Like, there's all sorts of things that need to be fixed. Okay. So we have these particles. I actually don't know why. I don't know why the river is not, or the mirror is not working. That might just be, well, let's see. Okay, let's go back here. Okay. See, I already, like, I don't understand why we have no green in this. Maybe it's being multiplied by a red frickin' texture. No, it shouldn't be able to be. So, like, what's going on there? All right. Like, I don't really know. Okay. This seems to make sense so far. Except for, oh, so these are additive blend right now? Okay. I still don't know what's going on. Like, why are they green? Right, because we set it to 0. And then set the W coordinate. Like, unless we're outputting this to an intermediate render target still. We must be. Okay, this must still... this is still getting multiplied by something. Or... I don't know. So we'll turn on depth test. So we're depth testing it against the ocean plane, but somehow not the land. That's really weird. Oh no, we're drawing it at z equals 0. So what are we oh, we're depth testing against each other. So we have to depth right is false. All right. Better, a little bit at a time. Isn't the color mask masking out red and blue? What color mask? Oh. Oh. Yeah, that must have been for some other reason. Okay, this makes more sense. Thank you, because that was confusing me. I saw that, but my brain was just skipping it because I was like, oh, that's for something else. And it's like, nope. That's for this. Okay. This is good. Don't worry about the flickering on the land there. That's just because we're generating these at z equals 0. We could bump it down a little bit. It would solve that problem. Okay, now we're at a place where we actually know what is going on. So if I go green, we're green. If I go blue, we're blue. Amazing how long that took, but that's graphics. Okay. Now, let's actually start doing something with this. Oh, guys, I know what was wrong with tagging it not being foam. It's that we don't notice changes to the particle entities until you restart the game. That's what happened. So next time I restart the game, it would have worked. And that's, again, one of those complications that you would rather not have. Okay. Like, this is a little messed up. So the spawning of the particles is off a little bit because it assumes, like, this is actually 0, 0, 0 on the map, but the ocean is down here. So we're going to have to fix that. Should we fix that? I think we should fix that. That's on the CPU probably. Like, so where was this freaking thing? So we still spawn particles on the CPU, I think, which is weird. Or maybe that's wrong. Let's see. I was just looking at this the other day. Yeah, like all this is a copy pasta of the CPU particle emitter that we're going to have to clean up. Or, I mean, ideally you do this particle spawning on the GPU, so we're kind of in this weird spot. I'm not particularly convinced. So, like this particle system has like 8,000 or 9,000 particles in it. I'm not convinced that's enough to bother with GPU particles, but maybe if we crank the number of particles up or have a lot of these, then it's like more like a GPU particle amount. How do I have 570 viewers? Well, what happens is people say, I would like to watch a high quality movie about the human condition and what it means to be a person in the world. And it's very serious and well made and well written and well acted. And then they say, well, there's no such thing anymore. Nobody makes those. I guess I'll watch twitch.tv. And they go on twitch.tv, and then there's like someone playing Escape from Tarkov, and they're like, well, I don't want to watch that anymore. I'm tired of that. There's someone playing Valorant, and they watch that for a second, and they're like, I've already watched 20 zillion hours of people playing Counter-Strike and Overwatch. And then they're like, I know, I want to go interfere with the productivity of people who are actually trying to program by going on their programming channel and making snarky comments that don't actually really try to contribute to anyone understanding anything. They'll just like distract the streamer. Who can I do that with? And they look down the page at all the, well, first of all, it's hard to find a programming streamer on Science and Technology, right? So you look down the page and there's like the pot farms and like the whatever. And you see like, you know, learning to make JavaScript Pong game in Godot or whatever. And it's like, well, I could distract that person, but it's mean because they're a beginner. And also there's probably not that much danger that that person is going to get a lot of work done, right? So why should I go to that channel? And then, you know, so they end up at the channels where maybe they could be most effective. And maybe this is one of them. I don't know. I don't know. I don't know how we get viewers. They just do that. They do these things. Yes, it also works in the opposite direction, where people get distracted from being productive by being here and listening to me complain about computers. Okay. So we're doing this spawn particle, and it probably has a spawn proc on it. I imagine it has to. Okay, it actually just assumes your gender. That's not good. So we want to set the position Do you render the character items that are mapped to bones in the character skeleton when you render each character, or when you render the list of items in the world? The character items that are mapped to bones in the character. So typically what we do, and this is a hack on this game that would not be appropriate for a lot of games, but this game isn't really about a lot of items, right? You don't find 1,000 different swords in the dungeon that all look different or whatever. So we actually have the items baked in to the characters as material lists, or as as little batches, little render batches of triangles that could be toggled on or off based on state. And so we just do that. So it's actually part of the character mesh. That works for some games. It's not good for other games. Okay, so here's the z coordinate. The x is going to be ocean.position.x plus sx times 0.5. So we're just putting it in the middle of the ocean map. This is kind of goofy. We shouldn't be doing this, right? We're just assuming right now, let's generate particles in a box around the thing. Eventually, we want a specialized procedure that just puts particles in the parts of the ocean where we want particles, which, like, probably not under the ground and stuff like that. Okay, so now we're almost there. We're like one square off for some reason. Almost. I know why we're half a square off. Okay, so we fixed the z problem, so that's good. I know why we're half a square off in x, roughly, but what is with the extra square? That I don't get. Oh, it's probably a divided by 2 thing. No, because we said times 0.5. Oh, wrong number. Okay, bro, that would help. And then okay. Yep, someone caught it in chat. That is good. Really, though, this should be in the spawn proc, right? So I don't know why I'm bothering to fix this way, except that I'm bad at making games. But this is better. So now this is a thing. Now, honestly, we should have these particles running in the editor as well, because you want to be able to, when you're editing the frickin' water, you want to know what it looks like. However, how about if we first make it look better? So here's what I want to do. I just want to make some wave particles, right? And I suspect that we're going to want them to output into 2 buffers. I suspect that we're going to want color and normal. But for now, I think we're just going to do normals. And what we're actually going to do So this is going to be a little crazy because these particles are so big. Like as soon as we start, like I showed with Casey, these particles are actually quite large. So if I go down here, whoops. If I go down here and say circle radius is that, like, wait, why did that only affect some? Oh, because it, okay. No, that's not right. So if I do that, that's like how much these particles are going to cover each other if I do a wave thing that I want to do. That's what they were designed for. It's going to be very hard to see what's going on. So I'm not sure what to do about that. I think in the beginning, when we make our default ocean particles, we'll just make way fewer of them, and then we'll add a way to toggle this and stuff later. So for now, there's going to be 1/20th as many particles. Particles per second. Particles per second. Did I give up on the paper idea? I didn't give up on it, but I think it's not really what we need right now. Okay, this is going to be a little easier to tell what's going on. A little. It's still kind of bananas, but it's a little easier. Okay, so here's what I just want to do. Do I have a UV within the particle? I'm pretty sure I do. Yes, vertex UV. I don't like the looks of this. That's probably a texture atlas thing. Okay. So we're figuring out the world space position for some reason. Scroll factor. Okay, so all right. I want UV noise right now. Let's make sure I don't mess up the shader. We've got a fresh bag of English breakfast tea that we be digging into. Sometimes these are hard to open. I don't like the design of these bags, but this one wasn't. Look at that. I don't know if you could see that, but I don't want to pour it all over the ground. Waste my tea. Okay. we are not going to want to oversteep this, let me tell you. That'll be bad. Okay, so what I want to do, what I want to work toward, is just making something kind of like little wavelets here. I don't really want them to be circular necessarily, although that might be the right thing. I actually want to use as much of the texture space as possible so that we don't waste fill rate. So I think I want to work on, let's make a little bit of a window. So you know, when you're blending wavelets together or whatever, use this property called finite support, which is that it goes to 0 outside some region. And you can achieve that, if you're not too picky about the properties of the function, just by multiplying it down to 0 as you get toward the edge. And, well, there are different ways to do that. We could multiply it by a cosine function, or we could just like linear ramp it. Or smooth step it. Yeah. Like a very simple thing to do is to just have a constant plateau across most of the texture and then just go down to 0 at the edges, right? If you're going to look and say, I just see red dots that do not look like water, then maybe you need to learn more about how programming works. Of course they don't look like water. The game's not done. The game is not done. Cosine would probably look more natural than linear. It might. I mean, it depends on what's on the inside. But yeah, let's just say, let's make a little cosine in one dimension, right? So we're going to call it window. We're going to say float window x is cosine. And so we got this uv. We're going to say uv.x times, it's called window because you can see the function in a narrow place and then it goes to 0 outside, right? uv.x goes from 0 to 1, right? And so cosine, or let's go sine, right? Because sine is at 0 and 0 at pi. How do you do pi in GLSL? Do you have to define it? I don't know if we define it as m pi, or it's not m pi. Oh no, uv. Really? Oh, that's a vertex particle uv. Like these bend and scroll like, no. There we go. Okay, vertex UV. Okay, so we're not using this variable yet. You know what? I could make my Emacs smaller so that we can see what happens as I type. That'll be more interactive, right? So we've got window X is this, and we're just going to say window X times 0.3. Okay. That looks approximately right. So now now we're masking by this circle, right? And instead, I'm just going to let's make the particle a nicer color, first of all. So let's just say result.xyz is vec3 of, let's make it a good cyanish color. So 0, 0.3, let's make it more blue because the background is more green. Okay, that is very easy to spot. Look at that. Let's make it dimmer though. All right, so is rotation random? Yes, it's being chosen by the particle system. We may not want that, right? Especially if a bunch of waves are going in a line, but that's something that we could deal with later. Okay, so now we're going to use that window to do the W coordinate. Okay, hold on. I've got to comment this part out. There we go. So that looks correct. We're multiplying by a cosine in one direction, right? And nothing in the other direction, right? So we can do a window Y. That's the same thing. And we do both of those, and then we do that. So now we have a square smudge. I would say we probably want more of a transition than that, maybe, except maybe not, because it depends on what we put in there. Like if what we put in there already kind of tends towards 0 at the edges, which is probably what's going to happen, then we don't need to worry as much. My tea is overflowing. Window could be based on distance from center. Yeah, except it depends on what you want, right? So like we just had a circle a minute ago, right? Which was based on distance. That is good if you don't want this squarish looking thing that we have. What the squarish thing lets us do is actually utilize more pixels. So if for a minimum amount of fill rate, we want to have the most overlap between particles so that we can have like wave motion where they interfere with each other, then this might be the way to do it. All right. Okay. So now, we of course can do this, right? So this is GLSL. So we could actually do this. Oh, maybe not. Oh, back to... I don't know if that was worth it, but whatever. Okay. So now what do we put inside the thing? Well, a wave. So this window is just to multiply the wave to the edges. So what is the wave going to be? Well, I mean, we could just have like another cosine function or something in there, right? Probably not. Oh yeah, no, we do want cosine because cosine is 1 at 0, right? Does he intend to have a color gradient? No, what we're going to do is we're making a geometric wave that we will then get normals of and use that to light the thing. All right, so it's going to be a whole process here. Okay. So let's just say the wave is a higher frequency cosine, right? We're going to do it in one dimension again. Cosine of 2 times pi times, I don't know, how many? 4 times vertex uv dot x. All right. And then we're going to normalize this. So this is a number between -1 and 1. And we're just going to say wave x times 0.5 plus 0.5, and we're just going to saturate just so that we don't go past 0 to 1, right? So then what? Well, we use that. We're going to multiply this by I wave x. All right. So that, now I'm not sure, window times opacity. There. So now we're fading in and out a wave of a particular wavelength. Right? See that? We're done. Ship it. No, we're not done. We are far from done. Okay. Right, so we can do the same thing. Whoops, I messed something up. Oh, back to. So here I've computed the wave in 2 dimensions, but actually no, let's do it. Let me undo that. Because we want maybe different frequencies. So the X wave is going to be bigger than the Y wave. right? So we're going to do the y wave and the x wave and product those together. Okay. So that's not great because why? So I don't understand that one. So that's just the x. This is just the y. That looks fine. So what I don't get, you know, why is this one black in the middle? That one is high in the middle. We want this other one to be high in the middle as well. Oh, because this isn't 0 in the middle. Right. This is frickin' 0.5. Right. The middle of the texture has UV of 0.5. Let's just say we're going to do that and that. All right, so this one is high in the middle. This one is also high in the middle. So if I multiply them, I at least get something that's high in the middle, but not that great. Maybe this is better. I mean, maybe we don't multiply by a wave in the other direction right now. Okay. It's a game based on any older ones, sort of. Sum instead of multiply. That's a good point, but I don't think that's really, well. I mean, I'm not really sure what's preferable. Like if we already have a window, this is just actually like doubling the window. I don't actually think that's going to be helpful. I think this is maybe honestly fine for now. Let's just experiment in one dimension. And we can get our multiple dimensions out of these crossing over each other and or other effects that we will do now. You know, this is like I'm looking at the particles and I'm like, why are we generating some of them so small and whatever? This is really a case where I would rather than having it hooked up to the CPU whole particle system, it just makes it really complicated. I'd rather just have a shader program that makes these things, you know. And then I can just tweak the number right away, which I can't do right now, without changing several things. Okay, so let's make another one that is higher frequency. So the question is, do I do it double? Is it like a harmonics? Or do I do it like with a prime number, a relatively prime, you know? So like we could do this. Is that right? Let's just do this every time. Okay. So I could vary the frequency of this other wave, like this is 8. This is 31. All right, so these are just, you know, constructively and destructively interfering. We could just see the smaller one there if we want. Anyway, there's a 7 bagger. There's an 8 bagger. And yeah. So the point is, you know, as with any kind of wave adding, we can build up successive you can build up complex shapes out of successive waves, right? And so you could decide to do that, and you could have different, like each particle could have a different combination of what the wavelengths are, right? And you just crank a bunch of them, right? So I don't know. Let me just, so you could also do something cheeky, like put other waves at an angle, right? So that they don't make such a straight thing. Let's not do that, right? Like a right angle is easy, but that's not necessarily that helpful. But if we wanted to rotate these by like 10 degrees or something, we could do that in the vertex shader and it would be pretty cheap. And then you could multiply these waves that are like slightly offset. So you would have a wave that's like mostly going in the same direction, but has a little bit of a more organic shape. Could you offset the phase with time to make some animation? Yes, that was what I was going to be, what I was going to do next, right? Because these, you know, just as static things, they don't look that wavy, right? But if you actually animate it, it does look wavy. That might make it hard to look at. Let's just do that though. So we're going to say float phase is, I mean, I assume we have a time variable somehow. Time. Let's say, how do you like wrap a value within an interval, like fmod? How do you fmod an OpenGL? Frac. Okay. I mean, that's fine. Does not define global function frac. Oh, it's fract, isn't it? I remember that. It's frac in D3D and fract in OpenGL. Okay, so we're not using this yet. We just defined it, right? And so, I mean, how would I do this? Okay, that's obviously not doing what I wanted. So this is if they're both going up and down at the same speed, right? So this is obviously a little bit of an artificial wave so far, but I would say let's work on the next part, which is just actually generating the normals. Because once we can do that, in fact, we can simplify this back down. Let's just get rid of this for a second. All right. So for this single wave, let's just generate the normals. And then, you know, normally, if you were being complicated graphics pipeline dude, you might write this into a normal texture that gets read by somebody else later for other purposes. And we could do that. But for now, I feel like we could just simulate everything in here. Like, assuming we know where the sun is, we just like do the dot product with the sun vector to the I vector and all that stuff, right? The thing is, I don't know. I guess we have enough information to do that. Nobody does deferred shading. Well, I mean, we don't even want to do that. Okay, so here's where my knowledge starts to get rusty, right? If I want to generate the normal, I basically want, it's like the gradient of the surface, right? And you can get the vector approximation to that. You just do a cross product of the two instantaneous vectors, right? So in one dimension, it's, and the problem is you probably need to include the window in that, right? So we want the derivative of window x times, you know, we could use just the CPU derivatives or the GPU derivatives initially and make it work, right? And then we can use that to sanity check us computing actual derivatives, right? The reason you don't really want to use like DDX and DDY is because those only have pixel resolution. Or like, you know, fragment, they're still approximations. Like if you have very high frequency details that are, you know, pixel size or smaller, they can easily get lost in that. And like with waves, you might want them to be pretty sharp, right? But in terms of initially getting it to work, we can maybe use those. So now I have to look up how to do this. Is there a GLSL equivalent to HSL, DDX, DDY? Look into DFDX and DFDY. All right. OpenGL. How does this work? OpenGL 4. Oh no, it's been there for a while. Specifies the express. Oh, you can do it on an arbitrary expression. Okay, so that's actually kind of okay, right? So I'm going to say like df dx of let's maybe we're accumulating gunk here. Right? And then ny is df dy of window only, because we're not multiplying anything by it. All right, well, we already broke something. What happened? I wave x. It's not, oh, because we defined that down here. All right. Okay, so we've got this derivative. And then how do we get the normal from this? It's the cross product of it's like something like this, right? I never do this in shaders, but derivative of cosine is minus sine, so you can just use the wave directly. I know that. That's what I said a minute ago, but it gets a little more annoying once we're adding a bunch of stuff together and changing it all the time and stuff. So I want to be able to implement this and have it as a sanity check so that we know that our other thing is correct. And also there's this weird thing where, so if we use df dx, we're automatically compensating for the rotation of the particle because this isn't screen space. Whereas if we do this derivative, we have to think about how the particle is oriented in world space and rotate it based on that, which is an extra complication, right? Do I differentiate between gameplay or engineer programs when hiring engineers, or do I expect them to have knowledge in each of these domains? Well, it's always good if somebody knows more than one thing. But we want people to be good at least one thing. If you're not good at least one thing, then I don't know, man. Okay, so Good at getting paid? Yeah, that's fine as long as you're good at something else too. You could be good at getting paid as long as you're good at game engine programming. You know what I'm saying? Okay. Let's just Stack Overflow it. GLSL use dfdx to get normal. I knew it. Now it's not exactly Stack Overflow. You can't. Oh, right. If this is a vector 3. Wait, what? That's weird. That's not a very good. Let's look for people who know what they're doing. Yeah, this is one of these threads where somebody's just like, I put some numbers in. You know what? We could just output. Oh, it's Android. We don't care about that. I just want to sanity check that what I'm doing is sort of the thing. This is a numerical error. Oh, it's Doug Binks. Like everyone's doing this based on position, which is not actually what. Well, I guess. Yeah, okay, this is just going to give us some z coordinate that we then need to decide. Yeah, okay. Let's go back. We have a world position that we're computing here, I thought. Wasn't I just looking up here and we were like, oh, here's the thing that computes the world space position? So these two. I mean, we can just get it by. I forget the name of the matrix in the shader, but we could just do a matrix. So particle position here, that's what we're looking for. So the more I think about this, the more that like getting these normals is annoying. Okay, so what we could do is say the actual position is I'm hoping this is interpolated correctly, right? And then plus, this is a world space position. Can I do const? And then we could use particle scale, right? Yeah. Oh, let's actually not const this. Particle scale times point. It's just relative to the size of the particle. We have some height. And then actually, I don't know if we need to put the window. Let's not even put the window in for now. Let's just do this. So this is a world space position. And we could do this, right? Like that. Whoops, except I have a redeclared variable. Okay, so we have this. And now let's just see what happens if we do this. Result.xyz is n times, we're just visualizing this number. Okay, well, it's really not, oh, n. This is like a vector from -1 to 1, so 0.5 plus 0.5. Okay, that didn't help. This is obviously not computing anything that we want. What does df/dx, df/dy do? Okay, what it does is, this hooks into that talk that I gave way earlier in the week. What it does is, you know, as it marches up and down the screen to compute things, right, it'll let you reference differences of a quantity between one pixel and the next. So what this does is, where are we? What this does is it actually computes this at neighboring pixels. It says, okay, what was the value of this to the left and what was the value of this one pixel up the screen? And then it subtracts them and gives you those numbers. So it's actually it's a very general mechanism, which is nice. But the fact that you're like using, you know, output of neighboring samples, you know, it has limitations. Okay, so like there's all sorts of things. Like this whole particle position thing. Like, I don't even know if that's correctly initialized right now. It certainly doesn't appear to be. Okay, so yeah, what's up, Casey? How's it going, man? How's it going, man? Trying to talk to people about JavaScript, yeah. I don't know what to say. Like, some people think it's great. Like, I've talked to people from the University of California, Berkeley, the place where I would have graduated with a highly esteemed degree if I had bothered to graduate. And they said stuff to me like, oh, but JavaScript solved the cross-platform software distribution problem. And I'm just like, what are you talking about? But I don't like to encourage, I should stop talking about it because I don't like to encourage JavaScript talk in the chat, because it always degenerates to JavaScript anyway, because people always want something to talk about that they don't actually have to think about hard or be correct about. So people are always saying JavaScript or Git in the chat or something like that. Switch to GitVascript, you know. So here's the thing. Even if my particle position is not correct, I shouldn't have zero gradients, because I should at least be getting height vectors. So I don't quite understand this. I should at least be getting gradients to the side, bro. Wait. Yeah, I should be. I don't know. I don't know, man. I can't talk to people about this stuff anymore. I had to sort of set the bozo bit on someone that Casey and I know, who is highly competent technically, but I just can't have a conversation with this person about certain things. So I don't know. The older I get, the more bozo bits I set on people, and eventually I just won't talk to anyone. It'll just be me in a room by myself. Is it Tom? No, it is not Tom. Although I'm tempted to set several bozo bits on Tom after that conversation. Oh my God. Okay. I need to set the bozo bit on myself because my gradient doesn't work. Am I sure n is from 0 to 1? What? N is a vector, bro. At this point, the bozo bit setting is outstripping memory bandwidth. Yeah, I mean, the thing is, I need to kind of give people more of a pass, because I think it drives people kind of insane more than they realize to like be in lockdown and stuff. Although the person in particular that I'm thinking of has like been a dick to me for years for no reason. And I think I don't know, I think it might be like have a social justice source or something like that. But no, it's not talking about George, but there's just somewhat, I don't know. I don't know. But you gotta, like, if people are extra dicks at this time, it's like, well, maybe they're having a hard time. I don't know. You know? Okay, so why do we think my gradient doesn't work here? I've never done df dx in OpenGL at all. And now it is true that the particle position doesn't work. So we could fix that, but I don't think that by itself fixes the gradient. But we're going to want that no matter what. Vertex attribute, particle position. Do I need to... I need to assign that. Like, I created the original template for this. It's been expounded on a lot, but this like shader system, I made it as a very simple thing years ago, and it's been changed a bit, and I've forgotten how it works, and it's like, ugh. All right. So, but yeah, like, I think these are the things that we can iterate, right? And we can read these out of the thing. So I'm going to hope that PT state has a member called position, because I don't know where that's defined. So we're going to say particle position is PT state idx.position. This is like reading out of the buffer. Oh, it worked? Maybe. I mean, we didn't barf. Okay, so let's go back to setting the color to be particle position. There we go. I mean, that's a nice interaction of a number that's way too high plus a tone mapper. Okay. So we're multiplying by 0.01, and you see the things on the right are brighter than the things on the left, right? And we're adding red to the right and green to the top. So this looks correct to me. However, I think this is just the position of the center of the particle. It's not actually going to help us compute gradients, right? We actually need the frickin' in the vertex shader, we need this plus, okay, let's do this up here. Vertex UV so that's in the XY plane times so we're taking, whoops, we're taking the UVs, we're going from 0 to 1 to -1 to 1, right? Oh, this is VEC3, not V3. And then multiplying by the particle size, which we should be referencing down here, particle scale. Which I guess we don't scale over time. So we're going to put this up here, and then particle scale. Whoa! I mean, that looks kind of cool, I'm not going to lie. I'm honestly not sure. Like, what? How are we... All right. Okay, that was just the shader freaking out. No problem. Okay, so in theory, we have a position that changes across the particle. And the way we can do that is maybe by saying, let's have the center position as well. And we're going to pass that around, and that's going to be constant. All right. And then what we draw down here is going to be minus particle center Hey, look at that. Okay. I... Okay, of course, this is still not rotated. This is not rotated correctly. So we almost have a world space position. We want to get to a place where red is to the right and green is to the north. Okay. I feel like there should be an easier way to do this than me doing this all by hand. Like, didn't we... It's been so long since I've done shader stuff. So obviously, to generate the quad, that got generated like by the compute shader that's running the particles. That one probably... I mean, almost certainly, it's easy for that thing to make the world space position for each vertex. And it may have done that, actually. So let's figure out where these things are defined. Okay, that's not it. I mean, so this is the thing that actually computes stuff for it. Oh, maybe it's in GPU particle? Anyway. So this is just doing some additional, okay. Generate vertex buffer item 6. All right. Okay, PT update default state. This is just doing basic particle physics in a non-frame rate independent way. Shame on you. So that's already a problem. Can't you get the world space position at each vertex and pass it through as an interpolated variable? What do you think I am trying to do? Can't you just make the video game? Can't you just make the video game have good water? Can't you just make the video game have Metacritic 99? Can't you just make the video game have world peace and everybody will be happy? Do I ever program drunk or buzzed? I mean, it's tempting to help me deal with chat by doing that, yes. Okay. Okay. I can't make a chartreuse because I don't have milk. I kind of could use a chartreuse right now. We might take a stream break in a couple hours and go get peanut butter M&Ms and milk from the store. Okay. Okay, so this thing just updates the particle position. Now, where is the thing? Generate vertex buffer item 6. Where would that even be? Vertex buffer generator, okay. Okay, so this thing, I mean, so it computes these world space positions. That's exactly what I want. It puts them in the vertex buffer. Great. Can I read that? Like, it's been so long since I've done, I'm just not in the flow of how this works. Like, somebody definitely, they were defining this stuff, and like, so I guess you get your vertex index somehow? So that I wouldn't have to do this UV stuff necessarily. So this is dividing by 6 because it's 2 triangles per quad. So this thing knows we're in quads. And that's the particle index. Okay. How do I get... So we actually might just have world position already because this vertex normal, vertex tangent are being fed in here from somewhere. So we have vertex position. So I think I've been a dummy from not knowing this, right? So I think oh, this thing right here, this position, I guess, is in world space down there. Whoops. Okay. So we're outputting this vertex position. Why we didn't do that in the compute shader, I don't know. Right, I saw that comment and just blazed past it. So like, so this actually, if I do this, that looks approximately right to me. Ship it. Ship it. It's a video game. You know, when people ask me questions and I say because the game's not done, well, now obviously the game's done. So what more could you want? I mean, just win the game now, you know? Just solve the puzzle, guys. What's so hard about this? Just solve the puzzle. Okay, this is good. Okay, so now let me get rid of the particle position because that's redundant with the vertex position. Okay. Whoops. Pause is vertex position. There we go. Okay, so now we're doing these things. And okay, so this still works. Commenting that out. What if we do this? That's supposed to be our normal, and it is still crap. It's almost as if oh, you know what? We don't actually want this. We don't want to saturate. So this actually turns it into a color. Let's do this. We're just going to do this. So I didn't expect that to make a big difference because I couldn't see any difference before. But so what we're saying now is like, look, it's whatever the position is in world space here plus this. Now this, I mean, I guess this is very small. Oh, there we go. We finally see something. There we go. It's like those candies that you get at the candy store that are really gross, like the square. It's kind of like coconut taffy, but not taffy. Do you know what I mean? It's like the worst candy in the candy store. Like, who invented that candy and why? Didn't they know there already were much better candies? Do not associate these with peppermint. Peppermint is so much better. Peppermint is so much better. Okay, so I guess this makes sense that, yeah. So really we want to normalize this. We want to normalize, we don't want to normalize police brutality. That's for sure. Okay, so these are sort of the vertex normals, and I don't know why we're getting white sometimes. That's wrong. It's not okay to be white in this case. That might be a tone mapper. But see how already, I mean, the Twitch chat or the Twitch compression might be making this more annoying, but already you can look at these and you can sort of see that they're a little blurry and pixely, and that's just because we're using derivatives. We're using GPU derivatives, right? If we were computing our own derivative, it wouldn't be like that. Yeah, black licorice is one of my favorite candies. Okay, why? So the white areas are probably when it goes negative. So are we not doing that correctly? Or maybe, let's bring it down. I don't understand that part. So first of all, why are some of them doing that and other ones aren't? Like, that's kind of weird. It's based on rotation. I'm actually not sure. I'm not sure that you actually get the normal this way. Maybe you do. Like, I'm not used to thinking about surface gradients. Like, these are two gradients, like, in screen space. The cross product gives us a thing sticking out of the screen, but that's not... Like, I just want a world space. No, that's okay. Okay, I get it. I get it. So I do believe this is the normal. But why are we getting white bands? Blue is good. So you want to see blue at the tops, right? That's like z equals 1. Or black at the bottom, right? Because at the bottom, you would expect it to, because we're mapping -1 to 1 to 0 to 1. So anything that goes by -1 goes down to the bottom. Yeah, the question is what's going on in the middle there? Licorice is a huge thing there. Yeah. When I was in Copenhagen and my friend took me to a candy store, they had like 17 different kinds of licorice. Lakritz, or however you say it. And we got a bunch. And I brought a bunch home with me. This was a long time ago. This was 2008, back when the world was young. But including the awful salty ones. Oh yeah, we got everything. When nobody in chat was born, that's correct. So, kind of want to know. Kind of want to know what's going on here. Here's what we do. Okay. I'm not sure that so already I'm not sure that this is right. Oh, maybe it is. Red, blue. See, this looks too symmetric to me to be good normals, because I want to see red off the hill to the right, bright red, and then I want to see dim red off the hill to the left with blue in the middle because it's facing up. That's not what I see. And so somehow this isn't right. Shouldn't the top be green? No, because nothing is pointing along the y-axis in this example. It's a wave where the surface normal should be plus x or minus x at all times. Or in the xz plane, let's say. There is no y component whatsoever here. Okay. Do we not have m pi? Really? So there we have white in the middle, which is weird. Actually, no, we do expect that. Okay, that's sort of a tone mapping thing because it is generally upward, right? And then we have some red component and some green component. And so we have all three colors. So maybe that's fine. So this is weird though. Because why do we have so much red here? Let me make sure we're in the coordinate system I think we're in, but yeah, y-axis, x-axis. Okay. You don't see red? There's red in there. Wouldn't disabling tone mapping help? Maybe. But then I have to go investigate how to do that. Just make your video game do everything. So why are we not getting any green? It's because for some reason like we do have this thing happening where we're generating this wave in texture space along the x-axis, right? If I change this to y, well, we also don't have green. We definitely can get green. That's fine. Maybe it's just that the water behind is green and that's making everything confusing. You know what I mean? Like maybe it looks non-green by comparison, but then where's the frickin' red coming from? You know? This might actually turn it off. Let me see. Yeah. Can you turn off the opacity? Why? Okay, but okay, wait. If we stop drawing this and we just draw the thing, what happened to our phase? Oh, no, it's there. But, okay. I actually don't want that to be the phase. I actually want to multiply the amplitude. I want the amplitude to be and we actually don't want phase. Phase there is going to be handled by moving through space. All right. So then I mean, this is going to be more annoying, but you know what I'm saying. So like these waves are going up and down in place. What does the Vec3 do there? It makes that cyan color that we're using as our base. Standing wave, exactly. I mean, it's going a little slowly so that it's now oscillating slower than it takes us to fade out. But like if we crank it up, there we go. That's a video game. People think that like I don't know how to make good video games. And all I can say about that is, bro. I'm actually not sure. I don't think this is actually working right. I mean, I expect to see more in between. That's probably the tone mapping, actually, preventing us from seeing the in-between. Like it's, or not exactly the tone mapping, but the fact that it's HDR, right? So the in-between states, we probably pass through very quickly relative to the, because of the squared nature of light intensities. Something like that. Okay. Anyway. So all that is just to say, I actually wanted that because then if we go do this, so we're still doing red here. I don't know why. Okay, let's make the wave extra smooth. So that's like one thingamabopper. And if we rotate this back the other way, See, this looks good to me. For some definition of good. So this is 180 degrees off of this, and the normals point the same way. So that is like correct for that dimension. What I don't understand is for this orientation, what's going on? Let's just damp out the green. It didn't like this. Okay, so there is green in there. It's not super strong. That might be our tone mapping, for all I know. What if I do this? Like, why are we seeing so much red? That doesn't seem right to me. I don't want to be seeing any red. You'll get into trouble trying to additively blend normal vectors. It would probably be better to blend height maps and calculate normals in water shader. Yeah, probably. Probably. But we want to get something for, like, we're just trying to get there. We're trying to get to the point where we have that problem. Also, though, if you just add the bivectors, or just, you know, add the input, like it, I don't know. I need to think about that. So why do we have red? I mean, let's look at this again. So let's look at the delta. No. Let's say so this should just be in Z. Okay, that's what we expect to see. So that's more blue where the wave is higher and less where it's lower. It's basically this, right? So we're subtracting back out. Okay, so that's just a sanity check. Yeah, I feel like I'm not actually getting the surface normal exactly here. Although it should be, especially for this rotation, it should be. Like there just shouldn't be any red when we view the normal. except maybe due to numerical error. Like if the quantities we're dealing with are so small, but it shouldn't be that bad. Do I need to make all my y normal values positive?
I don't know. Do I need to do that? Do I need to do that?
Sorry, I was speaking very quietly into the microphone. Keep your social distance with the mic. Okay. Why are we seeing what we're seeing? Okay, this is correct. This is fine. I'm happy with this part. Or no, not. I'm happy with this part here. That is fine. This part I am not happy with. Let's just graph before we add the height, right? Let's go back to this. Okay. That is putting green where we want it to. So a derivative in the y, let's do this. That's what I would expect. I mean, we could put this here. I don't see how this helps at all because the derivatives, particle center should get subtracted out from the derivative. It didn't do anything as predicted. Shouldn't you be multiplying dx times dz? Maybe. Like maybe I'm just not thinking hard enough about what I'm doing here. What I'm trying to do is get the surface normal in world space of the thing. Right? So we're taking, so df dx is just going to be one vector along the surface aligned with the x, whatever happens to be the camera x-axis, right? df dy is going to be whatever happens to be the y-axis, so that's going to be some other thing. That's just two vectors along the surface, and we don't actually care how they're rotated because we want the thing orthogonal to that, right? So this is just, should be, unless I'm really confused, this should be the vector in world space going out. Doesn't result equals n times 0.5 plus 0.5 mean there will always be red channel? Actually, yes. Wow, I'm dumb. I'm dumb, thank you. So the answer is, that I've been confused about for an hour, is because we're converting -1, 1 to 0, or -1 to 1 to 0 to 1, 0 maps to 0.5, and so with 0 red, you would expect to see 0.5 red. Instead of doing this, why don't we do an abs? Why don't we do 7-minute abs on this? Okay. So here we have a normal. I don't know why I don't see any green. There's so much crud down here that who knows what we do to it later, but I mean, maybe there is green in there somehow. I'm a little bothered that I see mostly blue, but that might just be because it's kind of flat. So let's go again. Let's turn off the blue equals for a second. Okay, yeah, that's what we expect to see. Look, there's green and no red. And then we'll rotate it. And now there's red and no green. Green and no red, and then red and no green. Or diagonal. Okay. Now, whereas we sat here and I was confused for longer than I should have been about something dumb, it's actually very important, especially when you're doing shader stuff like this, where you get fast visual results. It's actually very important to sit here and make sure that what you see makes sense to you and that you don't keep going until you establish that, even if you're confused and it's correct, right? And the reason for this is because the failure mode in shaders is that you just kind of get something that sort of looks like the thing, and you think it's right, and it's actually wrong in 5 different ways. This happens all the time. And then it's not nearly as good as it should be because it's wrong in 5 different ways, but you don't know that because you never like established correctness really, right? And so that's what we were doing, was establishing correctness, and I was confused a little bit. But then we got unconfused and moved on. So there we go. So let's go back here and let's go back to 4. Isn't that better? Okay, next. Well, we want to actually pretend like we're lighting this for now. And so let's pretend for a minute. We're just going to pretend it's a diffuse surface. All right? We're going to do diffuse lighting on this, which doesn't really make sense, but we're going to do it anyway. We're going to say diffuse light dir is at normalize vec3. It's in the x, no y, and so it's along the x-axis but up in the air at 45 degrees, right? And so then we're going to say vec3 diffuse dot is dot product of the normal with diffuse light dir. And then we're going to say result.xyz is abs, or no, not abs, saturate diffuse dot, right? That's not right. Oh, it's not called dot product, it's just called dot. Float to vec3, where? We don't have correct line number error reporting, which is super obnoxious, and I have to fix that at some point. Implicit cast from float to vec3. Where would that even be? Not this one. Oh, this. Okay, hold on. Let's go back to fruit stripe here. That's not fruit stripe. That's fruit stripe. Okay. We're not pumping up the magnitude anymore. Wait, why are we not seeing yellow? Oh, we sort of are. Okay. So diffuse light direction. Oh, this is a float. Duh. Okay. Okay, that doesn't really look correct to me. Although maybe. Maybe it's right. Because you can't exactly tell because, like, it's a wave. Let's put the frequency back at 1. Okay. So that actually, let's go back to this. Okay, so they're all facing the same way. Okay. Now I feel like the dot here should be 0. But it might just be really, really low. And again, we have the tone mapping thing. But diffuse light direction, dot product of the normal with that. No, I guess it won't. So if that's a little bit, yeah, no, this would have a positive dot product, right? If it's like pointing that way, kind of, and the light's over there. Problem is if I reload this shader, if I move the light direction, we reload the shader, so we can't really like move it smoothly. Oh yeah, we can. Here's what we do. So we have like a moving light source. Oh, we messed something up. No frack. It's maybe moving too slowly. Okay, so we're moving the light source around in a circle above this thing, and you see how the dot product is shifting forward and back on it, right? Isn't that great? Okay, so unfortunately, I would expect to see something a little bit I mean, it is sort of idealized, but I would start to expect by now of this looking at least a little bit like a surface of some kind, like my eye to read it that way. But that is not what is happening. So we may still be getting something wrong. Having the particles be alpha blended makes it confusing, maybe, but there's lots of times when they're not alpha blended. Or, I mean, maybe alpha blended to the background, you mean. We could definitely turn off the alpha for a little bit. That actually does look better, doesn't it? Like, I believe that, sort of. Let's actually, instead of, so right now it's circling around like directly overhead. Let's actually make it way around. So one thing that's very artificial about this is these don't have any sides. They're like perfectly... Yeah, I think this is right. I think this is right. I mean, it doesn't look right. Is there a similar game with water I'm going after? No. No, this is just going from the gut. And we're going to see how far that takes us. Okay, we have this thing. So the question is, now what do we do? I want to go all the way and do specular instead of diffuse, right? So the question is, how do we do specular? Because ocean water is very specular. Okay, well, let's just see this. Get specular output for sunlight. Just picking a random color. The light direction, the vector, I guess that's the I direction. The surface normal, the diffuse dot, and the power. See, okay. Oh no, that's fine. Specular power, I don't know, 7. That's not that high. So we need the sun and the, I guess that's the I vector. Wow, these things going on in the background are kind of driving me nuts. Let's just say sun direction and we might have to revert these, or view direction. Let's just see what happens there. Unexpected floating point constant. Oh, you can't do this. Okay, so that's supposedly like specular, but it's weird, right? Because it's one-dimensional. Let's slow this down again. Let's slow down the oscillation. Oh, we can turn on the amplitude again. Okay, let's keep this. Oh, the diffuse dot we're lying about. So let's just say it will be consistent between our diffuse and specular. I mean, I kind of believe it. Kind of. Let's turn back the alpha on. That makes it less obnoxious. Now there are a bunch of blurry smudges again. Actually, we could just have them fade in. Can just take out the window part and just have them be less obnoxious by fading in and out, but then staying. And then well, let's put back some other waves, right? So like I kind of want to make some rotated UVs at this point. Just because I want to start making a weirder shape and just make sure that, but we can do this one. Um, oh, we're not using the specular yet. Hold on. Folks, I have to actually, this is still just diffuse. Right? I did this spec. Oh. Never mind. Okay, that. Okay. Why some of these guys have no specular, I'm not sure. Going to have a weak diffuse component and a strong specular. Okay, the guys with no spec, it may just be due to orientation because you're not going to see specular at some rotations. Let's put back the window for a minute. I mean, it's starting to look neat. Okay, so let's make this go. I don't know why we restart our compute shader. Maybe OpenGL does that when you update a shader. I don't know. It's probably our fault. Okay. It's looking reasonable. Kinda. Let's turn on some rotation on the particles. So we had this thing where you can go in your velocity, aim toward your velocity direction. Well, ddisp. What the hell are those supposed to be? I guess this is old. That's the forward vector. Oh, ddisp is the That's actually the target theta, right? So we can just get fluid vel. Okay, well, everybody rotated that way. Oh, gameplay velocity. Let's do that. Okay. So everyone not in flow rotates that way. So if in flow, what? This editor drives me nuts. Inflow, is that a float? Yeah. All right. So these guys are sort of rotating sometimes, and then the other guys aren't. They're rotating in a very frame rate dependent way, like whatever. We'll fix that later. Okay, I don't see the brightness changing as they rotate, which is bothering me. Like, it seems to be based on like the particle spawn angle or something. No, that can't be right. Maybe that's just a trick of the eye, because it is, once they're all lined up, it makes sense. Rotation looks a bit slow. Yeah, that's just, this is not a particularly robust thing, but it's just like, it's this number here. So, or it looks like it's that number. Yeah. Oh, actually, I guess I do see it changing with the faster rotation. Okay. Like, yeah, this is not the right way to do this, people, but for now we're doing it that way. Okay. Well, let's add a wave in the other direction so that we have more of a thinger, right? Let's actually freeze the amplitude again for a bit. Actually, that probably makes it easier to spot the... Oh yeah, you can totally see the change in angle as they turn now, if they live long enough. Okay, next. We're gonna add another wave. Looks like an X-ray. I'm not sure that's a very good... Let's make this a sine so that it's centered, right? I mean, the thing is, this is like already windowed. I'm getting hungry, but we're starting to have a thing here. We are definitely learning to have a thing. So in the end, will the wave pattern be authored? Unknown. Possibly. Possibly not. So if this is just going to be the specular right now, right? Oh. We could set this first. Ship it. It's a totally perfectly working video game. Why not use a Perlin noise function? Because we're not doing that yet. And you don't want, like, a Perlin noise isn't a wave. It's a different thing. It's just noise. Okay. So let's add a couple more waves. Okay, and then so I kind of want to model this as now, right? I want, let's call this wave Y. Make these X2, X3. All right, so wave Y is going to be a different thing. We're not adding it yet. well, we're just going to say 1 and like 0.4 because these get remultiplied down here. Wave y times height x. What are we missing? Sum x. That doesn't seem right to me. Actually, oh, you know what? All this stuff here, this times 0.5 plus 0.5 is not really good. Now I'm getting a headache from all this. Okay, so we're going to say, okay, sum x is wave x1 plus wave x2 plus wave x3 times 1 over 3.0 the average, right? That still then goes from -1 to 1. Actually, we'll do that. I don't want to have to do all this man. So like, you know what? For normalizing for the purposes of display, we actually don't care. We don't want to track that carefully because I want the freedom to change these scale factors without having to clamp it to exactly 0 to 1. So we're just going to say, wow, I'm getting a headache from this, guys. Congratulations. How does this look with the normal particle size? This is the normal particle size. So I don't understand why like, why is it going down to 0? So I want like a big wave hump across. And then I want the waves in the middle to add to that. I don't understand why it's going down to 0. That could just be an effect of us. Actually, it's not really. Could just be an effect of taking the normal and whatnot. Okay. Where do we compute window again? That's way up here. Okay, so my feeling is that I'm going to want to rotate some stuff. Okay, so (1/20th of a semicircle, so 1/40th of a circle, which is about 10 degrees. Well, we'll leave it there. So alpha, right? So float CA is cosine alpha. Float SA is sine alpha, right? And then how do you declare? So I can go mat 2. How do you subscript a matrix in GLSL? Mat 2 M2. Matrices. Okay. Are these column vectors or row vectors? So that's the second column. Okay, so we're setting column vectors. Is that how that works? Beta is m pi times minus O.07. Somebody tell me if I'm doing this wrong. Let me make this a little less headache-inducing. Maybe faster is not the play. Mat 4 ABCD No, mat 4 is a 4 by 4 matrix. I don't want a 4 by 4 matrix. Did you mean mat 2 ABCD? Is this how the game is going to look? Yes, you can buy it on Steam right now. It's called Stand on the Cubes and Get Your Eyes Checked is the name of this game. You can buy it on Steam right now. Early access, what are you talking about? This is done. Okay. Instead of this, we're going to say alpha and beta is particle random A. I don't know. If that's a float or what. All right. And then beta like, I don't honestly know. What those things return. Let's Seems fine though. Okay, it's about break time for me, but for the finale, not really the finale because we have much more to do. We disable this, and we see what it looks like when you have a party. It's the ocean of worms. Okay, yeah, everybody's sort of going up and down in unison because we're using time. It's a good point. There we go. Okay, so our next job. See, I don't know why it resets. It's doing something bad that really annoys me in the simulator where it like it doesn't wrap correctly every n seconds. So we're going to have to figure out that eventually. But the point being, this is still not supposed to be good waves at all, but we're back in territory where like it's kind of like waves, you know? And so what we will do is next stream, which will be later today, after a moderately sized break for me, we'll go back to writing this into a utility buffer instead of the color buffer, right? And so what we're going to write, so right now all these white coloration is coming from, we're like doing fake lighting on these guys. And we don't want to do that. We just want to like, well, we can just write the height into the utility buffer and then use the derivatives on the other side to do derivative on the height and then color the ocean that way. And now again, that does cause problems, but well, maybe we can write both and we can see what the results are of each one. So we can write the normals in, and when you write the normals in, you usually ignore the z component because you know everything is up. So you just write the other two components of the vector and you reconstruct the other one. And then yeah. Hey, this ocean almost looks like Perlin noise. Well, go make your game with Perlin noise and we'll make this game. Perlin noise is good for things, but not for what we're trying to do here. It's not the right tool. This went from what am I looking at to this is pretty good. Well, it's not pretty good, I'll tell you that. However, it is not the worst, all right? So we will go from here to something more reasonable by the end of the day. That is the plan. Looks like a pipe cleaner train, yeah. Yeah, I mean, that is one way to say it. Frequency of the river waves could depend on their velocity. That is true. There are all sorts of things that could happen, right? And so we're just getting back to a place where we can do these things. The streams are quite reasonable, just the bulk is meh. Well, you don't even know how it looks because this is not the correct way to render this. So you don't know how meh it is, and neither do I. Now, do I think this is what we're going to ship? No, I do not. However, we don't really know till later what this is really going to look like. And it is quite possible that we'll want something else entirely for that. Like, it's quite possible that we only really want this wave thing that we're doing right now for the rivers. And that for other stuff, we'll want other stuff. We'll see. Lots of stuff to do, like the particles all go at more or less of a constant speed in the river. I don't think that's correct. There might be some spread to it, but it really should be a lot more. I think if you see slower stuff in the river, though, it's from things that are just outside that are overlapping or something, right? So some particles are oscillating uncontrollably from time to time. Like where? You sure you're not just seeing aliasing? Or like that could be, I think I see what you're saying. And that, I think, is just moire patterns from overlapping guys, which may also be a problem when we go to actually render, but, you know. No, I see what you're seeing, but, oh, maybe, no, that is, never mind, that's not moire patterns. It is guys who are freaking out. So yeah, we're going to have to, there's lots more to do here. Like, what we're going to do is use this for our basic wave pattern for a little bit. This is not like a good wave pattern, but it's enough to experiment with. And then we just go back and start doing some other stuff with it. But yeah, you're right. Some of those guys are freaking out. Like when it's like when they're at 45 degrees or something. So there's something, there's that function in there that's like find the closest angle to rotate where we want to rotate to. And that seems to get confused at 45 degrees. So we're going to have to look at that. We can do that now, right? So there was this thing. It's this shortest. I don't understand what this is supposed to be doing. Like this is old stuff that was commented out. It's like, okay. This thing is kind of trying to do a slurp by converting to theta and whatever. This is not, okay, this is not how to do this. So we're going to say this is the delta if dot of diff with, we don't have a forward vector for the particle. Okay. We could do that. We could negate the dot. We'll just say if diff is greater than 2 times m pi, diff minus equals 2 times m pi. Or no, if it's greater than pi? Because you... I mean, I never know. So first let's get it into 0 to 2 pi, right? And then wait. Okay, this is not as complicated as I'm making this. Let's just do this, right? Do that. I don't know. No m pi. Is it 3589, 79, 64, 23, something like that? I know I got something wrong in there. That equation with a tan 2 is usually used. What are you talking about? You mean this? No. A tan 2 is how you convert from a vector to an angle. That's all it is. It has nothing to do with perspective. Okay, do I see anyone freaking out now? I don't think I do. A tan 2 is literally give me the angle in radians that corresponds to this vector. That is what it does. Saw freak out mostly in the lower left corner. Yeah, okay. I mean, this is fine because like all of this has to change eventually anyway, because like I said, this is a very non-frame rate independent behavior that's programmed in here right now. So we just want to get it looking pretty good, and then we harden it and all that. So yeah, I'm going to take a stream break. 4 hours is about how long I like to go, and then I take a break and get some food or whatever. A tan 2 sin cos is typically used to create what, dude? Are you like a parody account where you're like Dr. Fauci because you say things that are like sound like they could be right but are actually totally misleading? Is that like your gimmick? Like what? Like what? Typically used to create perspective projections. Those are definitely words that occur in graphics programming. I will hand you that. It's a good gimmick for a Twitch troll account name if that is in fact the gimmick. Although, except I've never seen any of the Dr. Fauci videos, so maybe I don't get it because I haven't seen those. That is correct. Don't be a dick. No, it is not correct. Dude, what you're saying, okay. If you're actually serious, you have a little bit of a case of Dunning-Kruger here, okay? Saying atan 2 of 2 coordinates is typically used to create perspective projections is nonsense. And anyone you are saying that to who actually has experience knows it's nonsense. If you do not know it's nonsense, that's not bad if you're a beginner, but you have to understand that you're a beginner, okay? And you have to understand that, like, just because maybe you saw that in some code somewhere that did some perspective thing, but that actually has nothing to do with perspective, okay? And it's a widely used tool that does a lot of things. So just realize where you are. All right, dude, I can't. Okay, listen to the advice I just gave you and don't argue with me until you understand that advice, all right? Because just when you're in a hole, stop digging. That's all I'm saying. atan 2 sine x cosine x equals x clamped in range. I mean, it's a very expensive way to do it, yes. Why not atan 3? I mean, you just have to understand, this goes for anybody, right? If you're a beginner and you've learned some things, you've seen some things, and you recognize some things, that's good, right? That is experience that you are building up. But video games are really, 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 really hard, and there's really a lot to know, right? So if you have even a year of experience, that sounds like a lot to a lot of people. Like, that's nothing in video games, all right? It's nothing, a year. I mean, plenty of people have more than a year's experience sitting on a toilet, right? Like, by the time they're in college. So it's like not a lot. And that's fine. You just have to realize that that's where that's where you're at. You're toward the beginning of this very complicated endeavor where there's a lot to know. Just realize that's where you are. That's all. atan 2 was blocked as sexually explicit for you on Twitch. All right. You're not a beginner. All right. What games have you shipped? And what did you do on them? I don't know why I'm arguing with a troll. Oh my God. This is my way of taking a break. Yeah, it's a bad way to take a break. All right. Thanks, everybody, for coming by. I'm going to go get food. Unfortunately, I'm in California again, where it's hard to get food. Yeah, no, dude, you're the one who's incredibly arrogant. Seriously. I'm not being arrogant. You're being arrogant. I'm just calling it for what it is. You're welcome. I don't want to make you mad and storm you off. I mean, welcome to the stream, and you're welcome to come watch and stuff. It's just don't say nonsense and don't say nonsense that's wrong and expect me to not contradict you. Like, that's just how it is. All right. Goodbye, everybody, and I'll be back before too long. I don't know what I'm going to do. The Starbucks are all closed, which is one of my main sources of foods now. All right. See you later.